Hello, good day! Ito nga pala ang inyong Sir Jello at mayroon ako ulit ituturo sa inyo na math video topics. Pero bago yan, huwag niyo munang kalimutang mag-subscribe sa aking YouTube channel na Sir Jello para maging updated kayo sa lahat ng videos na i-upload ko.
So, hello. Good day sa inyong lahat. So, for today, we're going to discuss all about trapezoids and its parts. So, there are two types of trapezoid. We have the non-isosceles and the other one is isosceles. So, the difference between the two is that on this side of the trapezoid, for non-isosceles, they are not equal. Unlike in isosceles trapezoid, these sides are equal or therefore congruent. So that's the difference between the non-isosceles and isosceles. Okay, let us now define what is a trapezoid. So, trapezoids, it is a quadrilateral with exactly one pair of parallel sides. So you will see here, we have a figure. This is an example of a trapezoid. So we have trapezoid ABCD. Now we also have the parts of the trapezoid. We have the base, which is the parallel sides of the trapezoid. So if you're going to look at this trapezoid, the parallel sides of this trapezoid will be, let us change first the color and thickness as well. So the base for this trapezoid, we have line segment AD and line segment DC. So these sides are the parallel sides. Okay. Next, we have the legs. So this will be the legs. That is the non-parallel sides. So we have line segment AD and line segment BC. Okay. Next, we have the base angles. So these are angles formed by a base and a leg. So if you have this leg and you have this base, these are the base angles. That is the angle formed by a base and a leg. So we have two answers there. We have angle D and angle C, angle A and angle B. So we have two pairs of base angles. And then lastly, we have the median of a trapezoid. It is the segment joining the midpoints of the legs. So if this is the leg AD, there is a midpoint at line segment AD, which is E. We have a midpoint for line segment BC, which is F. Therefore, the median of a trapezoid for this example is line segment EF. So these are the parts of the trapezoid. Okay. Let us move on now with the theorem or theorems on trapezoid. Actually, we only have one here. This is called the mid-segment theorem. So it states that the median of a trapezoid is parallel to each base and its length is 1/2 the sum of lengths of the bases. So as you can see, for this trapezoid, we have trapezoid COLD with median at FG. So our median here is FG. We have line segment FG. It states that the median of a trapezoid is parallel to each base. So you have line segment CO and line segment DL as our base. And the length of this median is 1/2 the sum of the lengths of its bases. So if we're going to write, our first base will be line segment CO plus the second base, which is line segment DL, divided by 2. Since the given is the bases, all we have to do is to add the length of the bases. So CO, line segment CO is 13 plus line segment DL is 27 divided by 2. So 13 plus 27 is 40 divided by 2. So our FG, line segment FG, which our median is 20. So the median here is 20. Okay, so that is the formula on how to solve for the median. That is the first base plus the second base divided by 2. So that is the mid-segment theorem. Okay. Next, we have now the theorems on isosceles trapezoid. So we have 3 theorems here that is related to isosceles trapezoid. Number 1, the base angles of an isosceles trapezoid are congruent. So if you're going to recall the definition of isosceles trapezoid, it has congruent legs. So whatever the measure of this side is congruent to this side. Since KN, line segment KN and line segment LM are the legs. Now, for number 1, we are referring to the base angles. So the base angles here, we have angle K and angle L as our first pair, angle N and angle M. So these are the base angles. So for number 1, it states that the base angles of an isosceles trapezoid are congruent. So say the measure of angle K. We're given the measure of angle K. Let's say 100 degrees. So if the measure of angle K is 100, then it is also the measure of angle L, since K and L are base angles. So if whatever the measure of K, that will be for the measure of angle. The same with N and M. Okay. Now for number 2, opposite angles of an isosceles trapezoid are supplementary. So we're going to use the same information that we have for number 1. The measure of angle K is 100, so as the measure of angle L. Now, since the measure of angles K and M are opposite angles, so let us put it here. Angle K and angle M. These are opposite angles. angle L and angle M. Okay. So these are opposite angles. So whatever the measure of angle K, since angle K is 100, you just get the supplementary angle of angle M. Okay? So if the measure of angle K is 100 plus the measure of angle M, since we're referring to supplementary, that is equal to 180 degrees. So the measure of angle K is 100 plus the measure of angle M is equal to 180 degrees. The measure of angle M is equal to 180 minus 100. So the measure of angle M is 80 degrees. So therefore, they are supplementary. So if we're going to go back to number 1, the measure of angle N is equal to 80 degrees. That is also the measure of angle M. Okay, since they are base angles for number 1. For number 2, these are the opposite angles, therefore the angles are supplementary. Okay, next, number 3. The diagonals of an isosceles trapezoid are congruent. So, number 3, the diagonals will be line segment KM and line segment LN. So, obviously, whatever the measure of KM is the same as LN. So, let's say if KM is 16 centimeters, that will be the same with line segment LN. So those are the different theorems with regards to isosceles trapezoid. Okay, so let us move on now with our activity, that so we can apply the different theorems on trapezoid and isosceles trapezoid.
Okay, so for our activity, we're given quadrilateral mat or MATH, which is an isosceles trapezoid with bases MA and HT and LV as our median. Okay, let us have first number 1. We're given MA equals 3y minus 2, HT equals 2y plus 4, and LV equals 8.5 centimeters. So we are actually looking for the actual length measures of MA and HT, and for the value of y as well. Okay, so let us have number 1. So we know that LV here is the median, and you have MA and HT as our basis. So we know that the formula for that will be the median of a trapezoid is equal to the first base plus the second base divided by 2. So our median, of course, is LV. You have LV equals MA plus HT divided by 2. Then we just substitute all the values. So we have LV, which is 8.5, 8.5. Let's erase this part. Okay. So 8.5 equals, our MA is 3y minus 2 plus 2y plus 4 divided by 2. So here, what we're going to do is to, since we have the unknown variable y, or what we're going to do is to cross multiply 2 to 8.5. So 8.5 times 2 will give us 17 equals, we just combine like terms here, so we have 3y plus 2y, this 5y, then you have negative 2 plus 4, that is plus 2. Then you just transpose 2 to the left side, so that becomes 17 minus 2 equals 5y. 17 minus 2 is 15 equals 5y. Then divide both sides of the equation by 5. So therefore y is equal to 3. So the value of y is 3. So we can now substitute the value of MA and HT. So we know that MA is 3y minus 2. So we have 3 times our y is 3 minus 2. It will be 9 minus 2. So line segment MA is 7 centimeters. Okay. Next, for HT, you have 2y plus 4, 2 times 3 plus 4, 2 times 3 is 6 plus 4, so line segment HT is 10 centimeters. So the bases are 7 and 10, and of course the median is correct at 8.5 since it has the equal difference from 7 to 8.5, which is 1.5, and 8.5 to 10 centimeters, which is also 1.5. Okay. So those are so the value of y is 3, MA is 7, HT is 10 centimeters. Okay. Next, number 2, we are given the measure of angle HMA, which is 115 degrees. Find the measure of angle TAM. So as we can see here, for number 2, the relationship of angle HMA, number 2, the measure of angle HMA, which is 115 degrees. We are looking for the measure of angle TAM. The measure of angle TAM. So if we're going to look at the figure once more, HMA is here, TAM is here. Obviously, angles M and A, or yung the middle letter of the name of that angle, M and A, are base angles. So, obviously, angle M, which is the middle letter of this angle or name, and angle A, the middle letter for the angle TAM, are both base angles. And we know according to the theorem of isosceles trapezoid, the base angles are congruent. So therefore, the measure of angle TAM is also 115 degrees. Since angle M is congruent to angle A with respect to the base angles. Okay? Next, let's have number 3. Given the measure of angle MHT, which is 3x plus 10 degrees, and MAT, which is 2x minus 5. So, angle H and angle A, or MHT and angle MAT, you will notice here that they are opposite angles. So for number 3, we're going to apply the theorem about opposite angles, which are supplementary in isosceles trapezoid. So let us write down 3x plus 10 3x plus 10 degrees plus 2x minus 5 degrees is equal to 180 degrees. Okay, MHT and MAT. This is angle MHT. This is angle MAT. Okay? And that is also equal to 180 degrees. So we can combine like terms here. So we have 3x plus 2x. So we have 5x. 10 plus negative 5, that will be plus 5, equals 180 degrees. So just transpose 5 to the right. So we have 5x equals 180 minus 5. 5x is equal to 175. So if we're going to divide 175 divided by 5, the answer is 35. So x is equal to 35. Now let us try to substitute the values. So we have 3x plus 10. So 3 times 35 plus 10. You have 3 times 35, which is 105 plus 10 is equal to 115 degrees, which is the measure of angle MHT. Now for the measure of angle MAT, we have 2 times 35 minus 5. So we have 70 minus 5. That is equal to 65 degrees. So the measure of angle MAT is 65 degrees. And you will notice that the two angles are supplementary. Because if we're going to sum, the sum is 180 degrees. Okay, last number 4. We are given AH, which is 4y minus 3, and empty 2y plus 5. So we're going to solve for y, line segment AH and line segment empty. As you can see here, AH and empty are both diagonals in an isosceles trapezoid. So obviously, whatever the measure of line segment AH will be the same for empty. Okay. We have to solve first for the value of y. Is equal to 4y minus 3 and empty is equal to 2y plus 5. Since the diagonals are congruent, so we can say that AH is equal to empty. Then we can substitute their values. So we have 4y minus 3 equals 2y plus 5. So we just combine like terms here. On the right side, we retain 4y, then transpose 2y to the left side. So we have negative 2y equals, on the right, we retain 5, and then transpose negative 3 to the right. So that is positive 3. So 4y minus 2y is 2y. 5 plus 3 is 8. Then divide both sides by 2. Y is equal to 4. So the value of y is 4. Now, we can choose between AH and empty since the diagonals of an isosceles trapezoid are congruent. So we can try AH. So AH is 4y minus 3. So we have 4y. 4 times 4 minus 3. We have 16 minus 3. That is equal to 13. So therefore, AH is equal to 13. The same with empty. So if we're going to check empty, you have 2 times 4, 8 plus 5 is also 13. That is the answer for number 4. So these are the different examples that we can apply the theorems on trapezoid and isosceles trapezoid. Thank you for watching, and I hope you already have the full understanding of the lesson about trapezoids. Thank you very much, and have a good day.